So we don't have directly for anybody, no, only due to point mass we know. So what is the formula? If there's a point mass, what is the gravitational field strength? It is given by Gm by r square. Will I agree? If there is a point mass, due to point mass, what is the field strength? Gm by r square. We don't have for a body, we don't have that one. So is it a ring point mass or it's a body? It's a body. So therefore what I do, I'll assume two elements like this. Mass dm, and due to individual elements of the field strength here, it should be equal to dE dash, and this will be dE dash. What is dE dash should be equal to? dE dash should be equal to G dm by r square. It should be towards that point mass, no line joining the point mass and this one. So we are showing like this. Then after this, what is the net field? I think y component will cancel. Now you can ask questions. Sir, for a rod, you assumed one element. Why you brought two elements? So what is the simplest approach is? About a point where you are finding out, about that point, if mass is distributed symmetrically. Sir, what do you mean by symmetrically? Means you take any point on a ring, it will be at the same distance from point P. I think cone, this is similar to like a cone. You take any point on the circumference of the base of a cone. At what distance? It will be at a distance of slant length from the apex of cone. So you take any point here, you take point like it. These are the points. So all these points, what will happen? Will be at the same distance from here. It is slant length only. So same thing happening. You take any element here on the ring, it will be at a distance r from the point P on the axis here. That's the thing. So then why you assume two elements? Whenever if a mass is distributed symmetrically about a point where you are finding out, you are going to assume two elements to simplify mathematics. The mass is not distributed symmetrically, then one element. I think this is a key idea when you're solving problem. So these are the some things which you are supposed to make a notice here. Why one element, why two element? And now here we assumed only one element, if you can recollect. We assumed only one element and we have shown that as D line. Will I agree this? The reason for that, there was only one there's no symmetry here. But sir, same thing for a rod. If it is, there's a finite rod only, then let it be about now it's a symmetric point, no? So now what you're going to do? You're going to assume two elements here. Got the idea? This is so it's now I say this is a bisector. This line, this point P is on a bisector. Now point P is not on a bisector. You can see clearly this length is L1. This is a very core central idea in all our numericals. The reason for that, here what happened, you get both x as well as y component. What about here? The y components will get nullified and the problem will become very simple. To minimize mathematics, I'll always search for, is there any symmetry? I think all of you by this time, symmetry idea, how mass is distributed here. Similar way the mass is distributed. Like that, I can pick up 2 points which are equidistant from point P. So I say mass is distributed symmetrical. So 2 elements will come here, 1 element. The similar idea here also. 2 elements we assume. So because of that, the y component will get eliminated. Fine. I think this is a very important part of the discussion, which you should carry on in not only this chapter, total physics, where all the symmetry of, if the system is having a symmetry, and if you are involved in any integration, yes, you must take help of this condition. Got it? Okay, now rest all mathematics here. So what is the net field? dE is equal to 2 dE dash cos theta. Theta will be constant. No? You take any point on a ring, will subtend an angle theta. with the axis, line joining the point mass, to the point P will subtend an angle theta with the axis. So therefore this theta is a constant. So I'll take everything. Two cos theta dE dash. Okay, dE dash first will expand. What is dE dash? G dm by r square. 2g, even r is also constant. So only it is what? dm. What should be the total mass? Since we assume two elements, no? Since we assume two elements, so therefore this will become 0 to m by 2. So the total field is given by 2g cos theta by r square m by 2, or gm cos theta by r square. What is cos theta? X by r. Further, what is cos theta? X by r. So this will become gm by x r cube. What is r? Root of x square plus r square to the power of 3 by 2. So the entire thing, this will become E is equal to gmx by. So this is the expression for the gravitational field strength on the axis of the ring. What can be at the center? This is on the axis. On the center, or at center, how much it will be? Put x equal to 0. It will be 0. So what is the field strength at the center of the ring? Will be 0, that one. Now look at this. It is something variable, no? At x equal to infinity will be 0. Means 0, it is 0 at the center of the ring. At infinity also 0. So if I, let me search for any maximum minima exists. So if I check it, no, if I differentiate this, dE by dx, after differentiating and equating to 0, I'll get at x equal to plus or minus r by root 2 on either side. Not only on one side, on either side of the ring on the axis. What happened? At certain point, it will have maxima, not minima, because 0 at center is there and at infinity is maxima. So now if I plot this total graph, I just directly putting, if you want, you can differentiate and check it. So we do get curve like this. You have to show, don't draw a symmetric curve. Don't draw a symmetric curve means don't end up like this here. Don't end up here. It will be 0 at infinity, no? So you have to extend till here. So here is what? It attained maxima. So what is the distance will be? R by root 2. And this is that maximum field. Okay, I get this. So we'll get it. So how to get that maximum value? In this given equation, substitute x equal to r by root 2. X equal to r by root 2. Okay, let me do that. So the Emax will be equal to gm r by root 2 r square. So one r cube will come outside here. R cube will come outside. Then this will be 3 by 2 to the power of 3 by 2. This will be 1 by 2 root 3 3 cube will be there. So 2 to the power of 1 by 2. 2 cube cube root. Okay, this will be 27. Anybody? Final value? Anybody? Final value? What shall I write? 2.
Sir, 2gm by root 3 into r square.
3 root 3 r square will come, no?
Yes, sir, 3 root 3 r square.
3 root 3 r square. Okay, so there's a maximum value of that one. Where do it will occur? At x equal to r by root 2. And that particular field, you should have this general idea, because we do get many application problems where a student must have the ring. I'll give another better diagram. I think that's able to understand. So how the field here will be like this. The field on this side will be in this direction. So like this different shape, for all those shapes, one must have a basic idea. That's all, nothing big is there. Okay, see once I'll scroll down. I think I can show maximum this much only. So we have proceeded with the two element. The two element symmetric is what very important. Please do understand. Many numericals are related to this idea.